Hello friends. In this video, we are going to talk about complex numbers. So you probably learned about complex numbers in your algebra class before this trig class, but we're going to expand on complex numbers, this a plus bi, and use them to help us simplify trig expressions. So you may remember we've got a plus bi represents a complex number. A is the real part. BI is the imaginary part. And when we put A and BI together, that creates a complex number, the real and the imaginary combined. So looking at that A and B, those coefficients, we can graph them in the plane using an ordered pair AB. So in order to do this, we're just going to think about the x-axis, that's our horizontal axis here, the x-axis, and then the y-axis going up, we're going to call that the imaginary axis. So we have a real axis, the x-axis is real, and the y-axis is imaginary. So for example, if we wanted to graph -4 plus 5i, that would be the point -4, +5. So -4, left 4, up 5 takes us about right here for point A. Similarly, for point B, well, on B, there is no real part. This is the same as writing 0 minus 2i, which would translate to the ordered pair 0, -2, and this point B shows up on the y-axis down at -2. So the absolute value of a complex number, well, really, as we move forward in math, we start to call these two bars magnitude, especially when we start to deal with vectors. So magnitude means the length or the distance from something. All right, so that's what absolute value is. Absolute value is the distance from 0. So in this situation, we have that the absolute value of a complex number, a plus bi, is equal to the sum of the squares under the square root, which is basically just our distance formula. So if we wanted to determine the absolute value of -2 minus I, that would be, putting bars around that, we'd say the square root of -2 quantity squared plus -1 quantity squared, which is the square root of 4 plus 1 or the square root of 5. And if we were to think about plotting this number, -2, -1, it would go right about here in our coordinate plane. If we think about that as being a triangle, these sides, we would list them as -2, -1, and that little tiny hypotenuse I've drawn in there, if we found that hypotenuse by the Pythagorean theorem, which is also related to the distance formula, we get this √5. So √5 means that's the length. Here, if I were to find the magnitude of -2i, that'd be the square root of 0 squared plus -2 squared, which is the square root of 4 or 2. We can see that B is 2 units from the origin because that's on a plane axis. Okay, so now that we've talked about that, we also have trig notation for complex numbers. And this trigonometric notation for complex numbers, this is going to build us towards our polar equation logic. All right, so let theta be an angle in standard position. So my theta is this angle right here. And the terminal side of that angle passes through this point AB. So what we're going to think about is that we'll call this our radius R, my horizontal distance across this distance, that would be the distance A, and then traveling down, the length of that side would be B. So this allows us to define some relationships. One thing that we store, we're going to say that a squared plus b squared equals r squared, or that r equals the square root of a squared plus b squared. And we do not need to use the plus or minus because the radius would also always be positive. Also, what we can say here is that sine of that angle theta is going to be b over r. We could isolate b and say, well, b is r sine theta. And then cosine theta is a over r. Or rather, a equals r cosine theta. All right, so let's go back up here and think about this trig notation, a plus bi, and let's redefine it in terms of our trig notation here. So if I have a plus bi, that's the same. A is equal to r cosine theta plus b is equal to r sine theta I. And we could simplify that by factoring out the r, and we could say cosine theta plus I sine theta. So this is the way we can now redefine our imaginary numbers in terms of trig. A plus bi is now equal to r times the quantity cosine theta plus I sine theta. So that's going to end this video for us. We defined a plus bi in terms of, there should be a little parenthesis over there, r and theta. We've talked about a new way, a trig way to write our complex or imaginary numbers. And then we also talked about the absolute value of a complex number. And we mentioned this idea that absolute value is distance from 0. And when we think about distance, we're beginning to call it this term magnitude. So moving forward, and especially once we begin talking about vectors, that would be the magnitude or the length of something. As always, email me if you have any questions. In the next video, we're going to talk about converting between our standard complex number notation and trig notation for complex numbers. So we'll do some examples of using these definitions we've just created.